Okay, so in this part of the test review, the last page, we've got a word problem. So it says, for several years, astronomers have kept track of the number of solar flares or sunspots which occur on the surface of the sun. The number of sunspots counted in a given year varies periodically from a minimum of about 10 to a maximum of about 110. Between maximums that occur in the years 1750 and 1948, there were 18 complete cycles. So before I answer any of the questions, I just sort of want to show you what this means. So we've got this time range from 1750 to 1948. What we know is that at 110, we were at a maximum, and at 1948, we were a maximum. The lowest we'd get to is 10, and we're going to have is a whole bunch of these things in here. That is clearly not to scale. So the question is going to be kind of what do we know about here and what do we need to find out? So one thing that we usually need to figure out is what's the period. So here's something helpful. We know that there are 18 cycles in this region. And if you subtract these 2 years, you'll find that the distance is 198 years. So if you divide 198 years by 18 cycles, you'll find that there were 11 years for every cycle, which means that this is the period. So we now know what the period of our graph is. And that's going to be helpful for answering the first question, which is, assuming that the number of sunspots in a year varies sinusoidally with the year, sketch the graph of 2 cycles starting in 1948. So if this is 1948, we know that it starts at a maximum, so that's our maximum. And we know that in 11 years, at 1959, we will also be at a maximum. And in another 11 years, at 1970, we will still be at a maximum. Halfway between these years is where we're going to be at our minimums, which the problem tells us is 10. So a quick sketch of our cosine curve here will look like that. To label our axes, these are sunspots, and this is the year. So the next question is, what is the period of the sunspot cycle? We already answered that. It's 11 years. And what that essentially means is that the number of sunspots varies from 110 to 10 over 11-year cycles. So sunspots change from 110 per year to 10 over an 11-year period of time. So every 11 years, we got a repetition in the cycle. Now we need to write an equation expressing the number of sunspots per year in terms of years. So we need to find where the middle line is for this graph. And there are a couple ways to do that because these numbers are a little bit bigger. One, you could just average the max and min. And if you average those together, you should get the number 60. Or if you find the distance from the top to the bottom, you should find that distance is 100. And then half of that is 50, which is going to be our amplitude. And if you count down 50 from 110, you'll get 60. So now we should have enough information to write the equation. If you start from this point, you don't have to, but I like that point, we're going to have a positive cosine function, so amplitude 50 cosine. We need to write the b value here, which is going to be 2 pi over the period, so 2 pi over 11. We have a horizontal shift in my answer of 1948 to the right, and then the vertical shift is up 60. And we're going to use this equation to answer D, which is we're supposed to figure out our guess for the number of sunspots in 2016. What that means we need to do is plug into our equation the number 2016. And the best way to simplify this problem would be to put this into our calculator. So I'm going to bring up my calculator, and I'm going to go ahead and type in the equation. But first, check your mode. Oh, there it goes. Check your mode. And make sure you're in radians mode, because if you're not in radians, this will not work. So it's 50 cosine, notice an open parenthesis, 2 pi divided by 11. That is going to have another parenthesis after it, 2016 minus 1948, 2 close parentheses plus 60. And if you run that, you should get the number is 80.77. So our answer turns out to be 80.77 sunspots. Now, E is a question we haven't looked at before in class, but you've done it in other classes, so I'll do it briefly. What is the first year after 200, which I'm assuming is supposed to be 2000. I guess it could be the first year after the year 2000, but I'm assuming it means the year 2000, in which the number of sunspots will be about 35. To answer a question like this, I'm going to turn to Desmos. So let's see if Desmos will pop up. There it is. And I'm going to go ahead and type our equation in. So it's y equals 50 cosine parenthesis 2 pi over 11 parenthesis 2016 minus, x minus 1948 close parenthesis plus 60. And you'll notice that you don't see anything. One reason is I didn't actually type in pi here. There we go. And we get a graph that looks like this. Now your graph may not look as nice as mine does. What I did before is I changed my x-axis, so it went from 1948 to 2100, and I changed my y-axis from 1 to 120, because I wanted to be able to see sort of the low point, the high points, stuff like that on my graph. Now the question is, what is the first year after the year 2000? So I'm going to show you the year 2000 on my graph. That's right here. There's year 2000. So we want a year after that year where it is first about 35. And so here is, actually, is that right about the year 2000? Let me zoom. Can I zoom in on this? Yeah, so looking right around here, so the green line here is the year 2000. Okay, so it's not going to be this intersection, because this intersection way up here on the year 2000, it's at 52 sunspots. So it's not going to get back down to 35 sunspots until about the year 2006. So that's going to be the answer to this question E. It's going to be roughly the year 2006. And I Desmos this to answer that question. Now, considering you don't get Desmos on the test, this probably won't be on the test. So last question is, after the year 2000, when will the next maximum number of sunspots happen? Now, we can answer that really without using Desmos, but I'll show you on the picture what it would mean. So if I scroll up here, there's year 2000. That'll show up here at the year 2003. So that's going to be the answer to that question, but, so it's going to be the year 2003. How could you do that without Desmos? Well, if you look at the picture up here, we know that every 11 years we're at a maximum. So we have maximums at 1948, 1959, 1970, 1981, 1992, and if you add 11 one more time, you get to 2003, the first year after the year 2000 where we're going to have a maximum. And that's it, the end of the review.